Okay, notes 2.5, basic I can never say this word. Basic derivative rules. Okay, basic derivative rules. So, starting off, we're talking about how to find the derivative of a constant function. Well, we know a constant function is a horizontal line. So if we think about the slope of a horizontal line, that slope is always going to be 0, which means the derivative of a constant function is always 0. Okay. Then we have a single variable rule. So this is when we're talking about, let's say, for example, y is equal to x. Okay, very simple. There's no other derivatives there. Sorry, not other derivatives. There's no other variables there besides that x, which means if we were looking at this type of question, we would just identify the slope, and that slope would be the derivative. So for example, since this is y is equal to x, the derivative is always the coefficient in front of x, which in this case is 1. Then we have the power rule. So the power rule tells us that if we have something to an exponent, we can take the derivative by bringing that number down to whatever was in the exponents and then subtracting 1 from the exponent. For example, we had x to the 4th, and in order to find the derivative, we brought the 4 down, that's what we see right here, and then we subtracted 1 from the exponent, so 4 minus 1 gave us 3. So the derivative of x to the 4th is 4x cubed. Okay. These are pretty simple when we don't have another number in front. We're just simply bringing it down. But let's say we have a number in front. For example, on part B, we're still going to bring that exponent down. So here's our exponent of 3. I'm going to bring it down to the front. But notice in front, I now have a negative 5. So technically what I'm going to do is negative 5 times 3. Well, that's negative 15. Then I'm going to still subtract 1 from the exponent, so 3 minus 1 gave us 2. So the derivative of negative 5t cubed is negative 15t squared. Some other examples if you want to pause and try them and see if you get the same answer. Okay, then we have the sum or difference rules. So this one is saying that if we have two functions that are being added together, we could simply just take the derivative of each function. Okay. Same with if we have two functions being subtracted. We could simply take the derivative of each of those functions. So for example, let's look at B. So right here we have this function being added to the next function, being added to the next function, being subtracted. Okay, so what we're going to do is take the derivative of each one individual. So for this first one, this is the power rule. So 5 times 2/5, which is 2. Subtract 1 from 5, we got 4. Then we move on to the next one. Bring the 4 down, subtract 1 from the exponents. Bring the 2 down, multiply 2 times 3, which is 6. Subtract 1 from the exponent. So technically there's a 1 right here, but we don't need to write that. And then notice this last part is a constant. And remember, the derivative of a constant is always 0. So technically this is minus 0. But we don't have to write that because that doesn't change our answer. Okay, let me pause right here if you want to try out these problems and then check if you got the right answer. Okay, then we have some special derivatives here. And those are the derivatives of the trig functions. So for sine, the derivative is cosine. For cosine, the derivative is negative sine. And for tangent, the derivative is secant squared. Okay, so these would be good ones just to memorize. Okay. Let's see. This is just going on and proving to you why the derivative of sine is cosine, why the derivative of cosine is negative sine, so on and so forth. You do not need to know how to do those proofs. Okay, the next ones are the derivative of e to the x. Well, the derivative of e to the x is always e to the x, so that's a nice easy one to memorize. And then the derivative of the natural log of x is going to be 1 over x. So for example, let's look at this one. Okay, so we have natural log of x minus 1 over x. 1 over x can be rewritten as x to the negative first power by the properties of exponents. And so I would be taking the derivative of the natural log of x, which is 1 over x, and then using the power rule to take the derivative here. So this would be negative 1 times 1, which is positive 1, and then I subtract 1 from the exponents, which gave me negative 2. But we cannot leave this as an answer because of that negative exponent. So instead, we have to bring this variable down to the denominator in order to make the exponent positive. So our answer to this, or our derivative, is 1 over x plus 1 over x squared.